Hey, how's it going guys? My name's Daniel, aka HashLips, and today I'm going to be showing you how to start building a metaverse. So what is a metaverse? Well, currently I'm roaming around in a metaverse called CryptoVoxels. Now, CryptoVoxels is pretty cool and it's based on an NFT collection where you can go ahead and buy some land. If we go to OpenSea, you can see this is the CryptoVoxel page where you can pay some Ethereum to own a plot in a metaverse, a 3D world that can live on your browser or a game engine, wherever it might be. It simply shows that you have ownership of a plot of land like this where you can extend and build upon. In today's video, I'm going to be showing you how to actually code a program like this using the browser and a library called Three.js. This is a library that can be used to do 3D things in the browser. We are also going to be looking at deploying a smart contract so that we can actually go ahead and buy some land for our small metaverse. This is going to be really a basic concept, but I'm doing this tutorial so you can grasp what happens in metaverses, and the basic concept is that we display 3D land based of a collection or some NFT that you own. If you are new to my channel, I make coding videos on the HashLips NFT main page where we talk about blockchain and I show people how to create things like NFTs in this space. Please go ahead and subscribe if you appreciate content like this. Give me a like and comment what you think. I highly appreciate that. I'm going to subscribe to my channel from my other account because I also have a main account which is HashLips NFT. We're almost at 60,000 subscribers, which is amazing. My new account is called HashLips 9to5 and I've posted one video there. Please go and support me there as well. There is where I will be doing vlog videos and things that I find an interest in, such as 3D printing, mold making, and technology. Lastly, if you get stuck at any point in the duration of you watching this video or any tutorial really, you can go to the hashlips.online website, click on these links, especially the Discord link. The community is growing and we over 17,000 enthusiastic devs and artists on there that will help answer your questions. Let's jump right into this video. All you need to get started is a code IDE. So go and download Visual Studio Code. It's free and download it for your operating system. Then after that, create yourself a folder. I created one called Metaverse. Let's now go ahead and open Visual Studio Code. Then just say File Open. Navigate to where that folder is. Here's my Metaverse folder and open it. Now we have the Metaverse space right here. We're going to right click and create a new file and call it index.html. Once you've done that, you will need to write the boilerplate that looks like this. I've added the doc type explaining that this is an HTML file, the HTML main tags, inside the header tags, and then a title, simply saying this is HashLips Metaverse. Then create an empty body tag. After each change we do, you need to press Command S to save the file or simply save it by File and then Save. Alright, perfect. So now we need some way to host this file live. We can use an extension. So if you click here on extensions and you search for the live server, you can type it in here, live server, and it should pop up with the live server extension, which looks like this. If you click on it, you can just enable it or install it over there. I have already installed this, so if I go back to my file, you'll be able to see that I have got a button down here saying Go Live. What the live server does for us is actually host our page locally so we can do some testing. It's also great because if we make a change, it will update the website. So there's two ways of doing this. You can either right click on the file itself and then you can just simply go and say open with live server, or you can just be on the file or literally just click on go live over there. It will say starting up a port and then it will host your file like so. You can't really see anything here, but if we jump back to Visual Studio and I type in hello over there, click Command S to save my file, then go back to the browser, you will see that it updates live. Now we're all set up to start coding our metaverse, so we can get rid of that. Okay, cool. So now that we have the base set, we can go ahead and look at the key component that we will need to use. And that is Three.js, the library, a JavaScript library that enables us to render 3D objects in the browser. It achieves this by using the underlying 3D API of Canvas and makes it easier for us to set up 3D scenes, import models, and so on. We're going to be using this, so let's click on the documentation. I already have it open here. We can see that we get to the documentation, and on the Create a Scene tab, we can click on this Three.js file. This will open the web page like this, which contains all the code and is the full library that we are going to use. So what you can do is press Command A or copy the whole file. So we're going to copy everything that's here by right-clicking, copy, and then you can also go to this URL if you can't find it on that page. Next, we're going to go to Visual Studio Code, right-click in our project and create a file called Three.js and simply paste the whole library in here. Remember to save this file because now we're going to go back to our index.html and import it here. In the body tag, what we're going to do is create a new script tag, give it a source, and the source is going to be pointing to the Three.js library, like so. Next, we would like to use modules. So right-click and create a new folder. We're going to call this folder src, standing for source, and then in here create a new file, and let's call it index.js. This is going to be loaded by the HTML, and then this is where all the execution will take place. For now, just to test that it works, we're going to console.log hi, and we're going to save this file. We still need to import it here on the HTML file in order for the program to be loaded into the DOM. So we're going to create a new script tag as well as a source, and we're going to point to our source and then index.js. Something important, just add the type, and the type is going to be the module, like so. Once you have this set up, we can actually go to our live page again and check what is being rendered out. So if we go to the page, we can see nothing is there. But if we right click and inspect, we can go to the console and we can see that hi was printed out in the console. So that means that the index.js file is being read and executed. Perfect. So now we can actually start with our program because we can read the index.js file. Let's go ahead and get rid of this console.log and see what would be necessary for us to start a scene, a 3D scene. So jumping back to the documentation, you can see that it's pretty simple. You need three things, which is basically a scene, a renderer, as well as some geometry to show, and then we're going to animate it for the loop to take place. So let's start off by doing these. I'm going to actually copy this code over here and go back and paste it in my space over here. Something that I would like to do is, because I don't like the computation to take place there with the window.innerWidth, and I'm going to quickly change it. So I'm going to cut this out and just refer to a variable called ratio. I'm going to create a new variable ratio here at the top and equal it to the window inner width and inner height. Let me explain quickly what's happening here. So firstly, to start off with Three.js, you need a scene. And here we're creating the scene on line 3. On line 4, we're creating a camera by referring to the 3.scene. Now you might wonder, where does this all come from? Well, remember that we imported the Three.js library, and this is where these objects and classes live. So we can create a scene, a camera, and the camera parameter takes in a few options. It takes in the field of view, the ratio, which I've just placed in a nice variable here at the top for us, and then it takes the clipping. So where is the camera going to start rendering stuff from? That's why the clipping start and the clipping end is two different variables, and also kind of the distance, what will be in your scene. It's good to know that if your scene is very heavy, that you can reduce this variable so that the browser doesn't have to render your entire scene, but it renders chunks instead. Then we have a renderer. So a renderer is needed to actually render, compile and produce what people should see. So you instantiate a renderer like so, and give it a width and a height for the renderer size. It's good to kind of give the full width and height of the scene itself. That way, we will actually be able to see the full extent of the 3D space. Lastly, we attach this element, this renderer, which is most probably, I guess, a canvas element, but we attach the renderer to the DOM, meaning that technically in our index.html, it will attach itself into the DOM and make it visible for us to see. If we were to run this, we will see nothing on the page, and that's because one last thing is needed. We need to tell the renderer to actually render something. So how you do that is by referring to the renderer, and you tell it to render, and it takes in two parameters here. So we're going to pass it the scene, which we've defined up here, as well as our camera. Now that we've done this, we can actually save it and go to the website and have a look. And there we go. You can see a full-on black box. Although we have this white trimming around the sides, this is something we can fix in HTML. Jumping back to the code, let's open the index.html file, and then inside the head tag, right below the title tags, let's actually add a styles attribute. In here, what we're going to write is we're going to give the body a style, and we're going to make the margin 0. If we do that and save and we go back, you'll see that we've got a full-on black scene where we can now start building out 3D objects. We can now go back to the index.js and continue our journey in creating our actual scene. So we need some geometry to fill the space, and I think a perfect thing to start off with is actually the ground geometry. Let's create a plane, a simple box that's thin enough to be considered our ground. Now, if we jump back to the documentation, and it's a good thing to always reference this, I can show you how we can create some kind of geometry. Now, let's go ahead and actually copy this first line. I'm going to do it back and forth so I can explain. I'm going to create some space over here and then paste it in there. The first line that we have to add is some geometry element instantiated from the box geometry class that Three.js provides for us. This sets out the blueprint of what we want to make. Then what we can go ahead and do is create a material. So a material we can create by also instantiating a type of material and giving it a color. So now that we have the material and the geometry, we can actually create a cube by copying this line and pasting it. This will create for us a mesh with it where the geometry will live, taking in the geometry as well as the material, combining it. But this will have not added this cube to the scene, and simply if we save this and go to the page, we'll see nothing. We still need to add it to our scene. In order to add the geometry to our scene, we can actually reference our scene that we've created up there. We can say scene.add, which is a function that the scene provides for us. And the thing that we want to add is our cube that we've just created over there. And that is what it takes to create geometry and add it to our scene. We add this mesh, and now we should be able to see it. But will we really? If we go back and we check it out, it is still blank. The reason is because the camera is on top of our cube and there's no way for us to see it. So we have to go back and actually reference our camera and change the position. Let's just add the 6 or 7 to our Z position. And now that we've moved it back, we will actually be able to view our green cube. This is great, but our image is currently static. What if we would like to add some animation or movements in our scene? Well, we will need to complete and actually add the animate section over here. Let me copy this function and let's go ahead and paste it down here, and let me explain what it does. So basically this is an animation function, and all it does is it calls this request animation frame and then it calls animate, which is strange because it's calling itself again. This happens to create an infinite loop where the request animation frame will continuously call this function. And what happens is it calls the same render function over here to add to the scene. So we can now get rid of this bottom render function, and this last line over here just instantiates this the first time. In essence, this animate function becomes our loop, our game loop. So whatever happens in here, this function will be called a tremendous amount of times every second. In video and film, we usually get 25 to 30 frames per second. I think this function runs at around 60 frames per second, I'm not sure. But what basically happens is every second this function will run. So if we want to animate something, we can simply reference the cube and then go and change the rotation of the cube. And let's go and change the X, and plus equals means that it's going to add to it every time. Once we do that, we go back and we can see our cube spinning. We can actually reduce the spin rate like so, and let's maybe add an extra axis such as the Y. When we save this and go back, we can see the cube spinning. But the color to me is like very shocking. It's illuminating some color and we can't really see the cube. So let's go and add a different material and a light. Now the first thing I want to change is this material. So let me change this material to a Phong material. Save it and let's jump back and see what's different. So I refreshed and now you can't see the cube. The reason is because there's no lights. Let's add an ambient light as well as a directional light. So the first thing is we're going to define a light variable and equal it to a new Three.js ambient light, and we need to give it a color. Now we're going to use a hex color, so similar to this, where this is green and we probably want to make it all white. Now we can use this light in our scene, but it will be too dim, and we also need some kind of directional light. So I would suggest we also do a directional light and equal it to a new 3 directional light, and we're going to make it white. But a directional light also takes in a value, a brightness value. So we're going to make it 0.5. Now that we have a light as well as a directional light, we can actually add the light, which is a bit weird, but we're going to add to the light, not to the scene. We're going to add to the light the directional light. Once we have done that, now we can add to our scene the light. We're going to add the light. Now, if we save this and we go to our program, we'll see we can see the cube again and it's bright green. So let's go and turn down the ambient value. So instead of making it pure white, let's make it 40, 40, 40. Save it, go back, and now we can see this nice light coming from a direction, which is top down, but we can actually see the shadows and so on, which is very cool. Let's go ahead and refine our project. We don't want the cube to just be spinning in mid-air. Instead, I'm going to turn this into our ground plane. I'm going to add the ground and then remove the rotation because it would be weird if our ground was to spin. Now, this box geometry, actually this object or this function takes in 3 parameters, which is the width, the height, and the depth. So for the width, I'm going to make it 50. Then for the height 0.1 and 50 for the depth. Once I save this, I can now go back and check my scene. we will not be seeing anything because the camera doesn't have this in the view. So we need to kind of position our camera a bit better. So instead of doing this, I'm going to actually set the camera position. So I'm going to say set, and here we get to specify the X, Y, and Z position. Let's try 5 and 15, and then 15 for the Z. Save this and go back. And now we can see there's our green floor. Now we don't want it to be green, so we're also going to change this. And let's make it into a white ground. There we go. We can see that the camera is a bit off, but I wanted to actually look at the ground because I want a slight top angle view. How I can achieve this is by going into this render method, and then on the camera we can actually set the camera to look at something. So we can actually say the camera needs to look at, and what does it need to look at? Well, we want to say ground.position, and I believe that is it. So let's do that, go back, and this is a way better angle because you can imagine that we will be having a lot of buildings popping up here very soon. This all works great, and we're on our way to creating our metaverse. Now let me explain the concept that we are going to be using going forward. I'm going to copy these 3 lines, then down here paste them in. I'm just gonna, for brevity's sake, just append a box in front of the geometry as well as for the material. Then I'm going to refer to this as my box. Now we're going to replace that and this so we can create a box. I want the box to be of a size 2 by 2 by 2. That's fine. And then it will place it in the center of our scene. We have to add it though. So what we need to do is say scene add and then add our box. That's how simple it is. If we go back to what we have, we can see that here we got this box over there. We can maybe change its color. So let's make it green again. Save it, go back, and there we can see our box. These boxes will represent actually the buildings that we buy as NFTs. So as you can see, we've got a width, a height, and a depth to play around with. We can also set the box's position. So if you want to set the position, we can say box.position.set and provide it an X, Y, and Z location. So we can maybe say the X should be -2, 0 for the Y, and for the Z, maybe 8. Save this and let's go and check our box's location. So the box have actually moved up now, closer to us, but it's going to navigate around on the plane wherever we give the allocated position. So keep this in mind. This is very important for our next step that we're going to take. But before we go on to the creation of the smart contract, let's create some kind of user input control so that we can at least move the camera around to some degree. But what we want to create now is a new module. So in the source file, create a new file and let's call this key input.js. Now that we have a key input, we're going to create a class and we're going to call the class key input. And while we have this, we're going to create a new variable and call it key input. And this time is going to be a lowercase because we're going to instantiate a new key input like so. And then we're going to export this, export default, and we want to export the key input. This way, we'll be able to import this module in our index.js file. So go back to the key input, and the things that we'll need is a constructor. For the constructor, we're not going to do much, but we're going to say this.keys. Now, this.keys refers to a variable inside of this class. Whenever you use the keyword this, it refers to the instance. For instance, if you create a key input instance, the this keyword will refer to this object and its variables. It's very important to understand this, but this is also a concept that we can elaborate on in future videos. So for now, understand that this is a variable custom to the key input, and the constructor is something that gets called as soon as we create a new key input. Then we're going to create some custom functions, such as isPressed. It's going to be one function. We're going to have a down function, so whenever we press a key down, an up function for whenever we release that key, and then we need our program to actively listen to events, key input events. So we can say window.addEvent, and an event is simply something that continuously listens for some predefined thing, such as a key down. And what we want to do is every time someone enters a key, we want to call our down function. So we have to refer to this.down, and then we're going to bind this. This will basically just refer to itself again. We're going to do the same, but this time instead of key down, we also will do it on the key up. But this time instead of calling the down, we also want to call the key up. So let's go and define these two functions quickly. So for the down function, we need to pass the event, and then we're going to simply set this.keys, which is this variable at the top. We would like to set its field name. So the field name is going to come from the event.keyCode, and this is a property that exists on there. We're going to set this to true. So the key code might be a numeric value, but it will also be useful for us to console.log out what is busy happening. So for instance, here I can just say, well, log the key down movement, and then specify and give me the key. So e.key, and then also the e.key code. And the reason why I want this is so I can configure the movements that I want to do. Now we don't want this to always kick off, so a good statement to put up top here is to already check if the key is being pressed. And how we do that is by checking the key code and making sure that if it's already true, we can simply just return. We are going to do exactly the same in the up function. So we need to pass the event, and what we're going to do is set this to false, because obviously we have now already pressed it and we've taken our hand off the key. For isPressed, this event simply needs to return to us something. We can return this.keys, and this is going to take in the key code. So all we need to check is the key code, and it's going to return to us if there is something. And if there is, obviously we need to return it. Else we're simply going to return false. And that is it. There's our nice key input class that we can now import. So let's go back to our module, the index, and let's actually import the key input from key input, and we need to append the JS. By simply importing this module, the event will pick it up and then actually run it. So we can just go to our console now, and if I press some keys, you should see that we get our logs. We get down, F, and then it was down again, and we probably need to change something and just make this to say key up. Otherwise we are going to get confused. So let's try that again, and there we can see I pressed F and then I released it. Now I'm pressing S and released it. So I can press keys on the keyboard and we know what key code they are. This is important because now we can use this to kind of manipulate the camera in a certain way. Now that we have our key input here at the top, what we can do is actually utilize it. We can go down here and say if the key input.isPressed, which is our function, and now we can use the value. So I'm going to simply use 38, which is the up key, and we can actually verify that by going into our program and pressing up, you can see, and pressing down is 40. So I'm going to choose the up key, and what needs to happen in the animate function when I press it? Well, I would like to set the camera's position, and I'm going to set the Y position equal to, well, plus equal to 0.05. I'm going to do the same to create like a smooth angle motion, and this time plus it to the X. We're going to do exactly the same. So copy this function and change this to 40, but instead of changing it in this direction, we're going to minus it. After doing this, we can go back and see what will happen if we press the down key and then the up key. You can see we get some angle change with the camera zooming into our building. Now we're done to the point where we have a 3D world and we can change the camera angle to point downwards and upwards. This is just done so we can get a different perspective of our actual metaverse, quote unquote. Because technically what we are creating right now is a small metaverse. We are displaying an NFT, which we're going to create now, in a digital world where we can kind of roam around in. The next step is to create and launch a smart contract on the blockchain. Now I do want to say everything I'm going to be doing and showing to you right now can be done on the Ethereum blockchain as well. I'm just choosing Polygon so that I can do it in a cheaper way. For this tutorial, I'm not going to be showing how to upload the metadata with images on IPFS. If you are interested in knowing how to set up an NFT collection contract from start, you're more than welcome to watch this How to Create an NFT Collection, the Ultimate Guide. You will learn each and every aspect of uploading a collection. I then highly recommend watching this lower gas fee NFT contract video over there, as well as uploading large files to IPFS. With this knowledge, you'll be able to launch the smart contract successfully, but what we are going to do now is adapt one of the smart contracts so that we can pull in data and actually, as people mint, render the NFTs as buildings in our metaverse. So go to the HashLips GitHub repo where we are going to reuse one of the contracts. The repo that you can go to is the HashLips NFT contract repo. You can also alternatively go to it directly by going to this URL. Then click on contract and search for the simple NFT lowergas.sol. Copy all the contents by clicking on that button and then go to remix.ethereum.org. This is an online Solidity compiler. Create yourself a new workspace by clicking on that little plus icon, and then let's create a new contract. I'm going to call this the hverse.sol. Now go ahead and paste in all the contents. The first thing that we need to change in this lower gas fee contract is actually this name. I'm going to call it the hverse, like so, as well as change this name over here on line 41 and make the symbol HVS. Setting the hidden metadata for the purposes of this tutorial is not really relevant because we won't be using it. But I'm going to set this anyway because I have that IPFS link. Like I said, if you want to know where to get these links from and how the metadata works with hidden data, then you can go ahead and watch these videos. For now, we are just going to continue and do the necessary adaptations to get this working. The next step is I want to change this max supply to be 12. I don't want a lot of buildings, and I also am going to make the cost 0 to mint. I'm going to start the smart contract off by setting the pause to false, as well as the revealed is going to stay false. It really doesn't matter. The next additions that we are going to make is important because we are going to reference them as if these were the NFTs that people minted. So what we'll need is a struct. A struct is basically a custom data type that you create. we're going to call our struct a building. And how we create it is like this. We're going to have a string for a name. Then we're going to have the width, which is going to be a uint, or actually a int 8. Then this is going to be the width. We're going to have an int 8 for the height, an int 8 for the depth, and so on. We also need the x as well as the y. And lastly, our z position. This is now our new building data structure. We're going to use that as reference when we load the metaverse to kind of see who owns an NFT, but not only that, to actually render the buildings as these buildings get minted. So what we're going to do now is actually create a new mapping, which will be of type building. This will be set to public, and we're going to call it the buildings. It's going to be declared like that, and the next step is to actually define some buildings in our constructor. Let's give ourselves a bit of space, and let's look at the goal. We want to be adding to this building variable some buildings that we are going to render. We know that we have a max supply of 12, so we're going to have to create 12 different buildings. I've worked out the 12 buildings pre-positions before, but I do have to mention arrays start from a 0 index, and our NFTs start from 1. So keep that in mind when you configure your NFTs and where the ID starts off. All that means is that we will be pushing a new building, but the first building that we're going to add by using buildings.push is that we're going to create a building, and this building is going to be the building 0. This is just to zero everything out and have a default building for ID 0 in our array. I just want to take a moment to explain that we are basically creating a new building that we are adding to this array by calling push. And when you push on an array, you're actually adding a new element. The element that we add has to be a building, and we typecast it as a building with a name 0, which is the first attribute, and then the width, height, depth, x, y, and z are all set to 0 in a chronological order. So a real building would look something like this. It will be the same. This time I'm calling it a house. The width will be 1, height 3, the depth 2, and then x 2, and then 0, 3, and so on. It directly correlates with the data type. And that is basically how it works. So I'm going to add 12 buildings to be exact, along with our 0 building. This is so that this can directly correlate to the 12 NFTs that will be minted. These kind of dimensions have been pre-worked out for me to see how the town that I'm building, the kind of quote-unquote metaverse town, is going to look. And these will be the available spaces for people to buy. So now that we have this here, and keep in mind, how you get the data on the contract is all up to you. You can also make use of the metadata, trying to keep it a bit more secure. Here I'm directly uploading it onto the contract. Now that we basically have a list of buildings, what I'm going to do is duplicate this total supply function. The reason is because I can reuse the logic, and I'm simply going to make a few changes to retrieve all of our buildings easily. I'm going to call this getBuildings function. It's going to be public, a view, and it's going to return not a uint256, but it's going to return a list of buildings, an array of buildings, and we have to add the memory. Now, only thing that we need to change in here is saying that we need to return our buildings. And there we go. We are done. We are actually done with the whole contract implementation. The rest of the contract will work exactly the same as minting NFTs. So we can now go ahead and deploy this on the Polygon network or Ethereum network. Like I said, we are going to opt for the Polygon network. Before we go ahead and deploy this to make it easy for us to verify, I am going to, however, make use of a plugin. So if you click down there, you can search for the Flattener plugin. There we go. So I have it active, and you can simply activate it like this. Once you have it active, you'll see a simple scroll on the left-hand side, and you can click on that. It's going to ask us to flatten the contract. So go ahead and click on Flatten. Once we've done this, we can click Save, and there we go, our flattened contract. This basically takes all the dependencies and puts them into one file, making it easier for us to verify later on. You'll see that we have an error, and that's basically because the flattening didn't take in our license, which we're going to keep as MIT. So I'm going to copy that, go to the very top of the flattened contract and paste it in. Then I'm going to say save, and you'll see we have the green tick. The actual contract is now all the way here on the bottom. You'll see this is our original contract with the changes that we've made. And there we go, the H-verse, it starts here. Now, the next step that I want us to do is actually go to the file structure. This is not the contract that we want to deploy. The flattener actually saved it outside over there. It has an underscore flat at the end, which is fine to use. We're going to make sure that we're on this contract, and then going to the deploy and run transaction section, we're first going to test deploy this on a JavaScript virtual machine. Then make 100% sure that the contract that you deploy is the H-verse, not any of the other ones. You need to make sure that it has the same name over there on the left-hand side. Once we've done this, we can deploy, and then we can actually open our contract at the bottom. The only function we care about is this get buildings function. Once we click on this, this should retrieve to us all our buildings. With the get building function as well as the total supply function over here, we are going to determine which buildings to render on our metaverse. There's a lot of ways to achieve this. Like I said, you can use hidden IPFS data or make it return only when you query it. But the whole purpose is to show how to create the metaverse linkage to MetaMask and the blockchain, and how to get this information now onto the browser. I am now ready to deploy this to the real network. Make sure that you have MetaMask installed for this process. Select the network of your choice. I'm going to select and stay on Polygon. Make sure that there's actual Matic or Ethereum, depending on which network you are on, in your wallet. Then I'm going to go to the VM environment over here and select Injected Web3. This will pick up that we are on the 137, which is Polygon network, and it actually picks up there. It says Ether, but this is technically Matic in my wallet. And now we can deploy to the real network. Keep in mind, these videos are for tutorial purposes, so always do your own due diligence when deploying these smart contracts. Make sure you always have an extra pair of eyes on these, and don't directly always just copy these code pieces and deploy them. Make sure you understand what you're doing, because I will not take responsibility if stuff goes wrong. That being said, let's go ahead and deploy this. So I'm going to click on deploy, and now that I've deployed this, it's going to pop up MetaMask. With MetaMask open, I can say let's confirm this, but I'm first going to edit the gas fee and make it of high priority so we get this deployed even quicker. The transaction will kick off, and then once it's done, we will see it pop up here at the bottom. There we go. It was successful. So this is now on the live chain, and we can check it by copying the address and going to Polygon scan. Once we're on Polygon scan, and this is exactly the same if you were to be on Etherscan, you can paste your address over there, search for it, and then we'll find the contract. At this point, it is very valuable to go and verify it so that we can actually do some calls directly from Polygon scan. So click on verify and publish. Then I need to log in. This is the verify and publish section. Now we can simply go ahead and select a single file and then select which version we used. We used version 0.8.7, the compiler used to compile the Solidity code. And that can be found if you go back to Remix, go here to the section, and there you'll find the version. We did not optimize it and keep that in mind as well. So let's jump back and select the license type, which is MIT. Then continue. You'll be presented with a page like this, and remember, optimization should be no. Then I can go back and copy the whole contract and then paste it in this section. Seeing that we had no constructor arguments, we do not need the ABI. So I can leave that blank, tell this thing that I'm not a robot, and then verify and publish. This is fantastic. Our contract is now verified. So we can go there by clicking on the contract address, and now we can see we've got the read options to our contract to read all the functions, as well as writing to the contract. We now have the option to mint NFTs either by going to Remix and doing it through this interface, or we can do it directly from Polygon scan. We will get to this in just a second. We need to finish off the connection to the Ethereum or the Polygon blockchain, and then we can display our houses as NFTs in our metaverse. Let's quickly code that and then see what happens. The first thing that we'll need is actually the ABI, the inner workings of our smart contract. So create a new folder, and I'm going to just simply call this ABI, and then a new file. And we're going to call this file abi.json. Once we have this, go back to the contract, then click on code and scroll down to this ABI section. You can copy everything, then get back to Visual Studio and paste it. Once it's now in here, and you can see I saved and my auto formatter formatted this for me nicely, this is telling us how the functions look like on the contract itself in order for our libraries to interact with them. The next step that we'll need to do is actually go to the index.html and import the library here. What is this library? Well, it is the web3 mini.js. This is actually the library that allows us to work with a smart contract. And we're going to use this to kind of help us facilitate working with the functions and getting the data back. After this, in the source directory, create a new file. This is going to be our connect.js script, and this is actually going to facilitate the connection to the blockchain. The first thing that we need to import is going to be the ABI script, the JSON that we just created this file from over here. So go and import it and then specify where from. So ABI, abi.json. In order for this to work, it's best if you say assert and then the type, we're going to add a type here. And the type will be JSON, like so. Great. Now that we have that, let's create a constant value and call it connect. This will be just a reference to a new promise. What is a promise in JavaScript? Well, a promise is exactly what it says. It promises to deliver something. And we are going to use this construct to wait for things like the connection and the data to come back before we deliver it and actually render something on our Three.js metaverse. A promise always takes a response and a rejection, depending if something went well or not. We're going to write an if statement and then check the if statement, and we want to check if the window.ethereum, like so, exists. and if it is equal to undefined. So if this is equal to undefined, it means that there is no provider such as a MetaMask extension. That's why I'm going to reject this call and maybe say install MetaMask, like so. Once we pass the test, we know that MetaMask is an extension in the browser, and we can now use it by going to window.ethereum, and then we can say we want to request something. The request that we would like to make is in the form of an object with a method. The method being something like eth underscore request and then accounts. If we did this correctly, if we save our page and we hook up our new controller just by simply referencing it in our index.js. So let's quickly go ahead and export this. So I'm going to say export default, and let me export the connect. Now I can go to the index.js, import connect, and then there it is. And then I can simply right off the bat call the connect function, like so. Once I've done this and I go and open the browser and I refresh, what should happen is MetaMask should ask us something. Now it says function connect is not a function. It tells me that connect is not a function. Now connect is a function, it's a promise, and we should be able to wait for promises, but I guess that's fine. We need to, then just await it like so. And we will await for something to happen. We can even write in here to console.log hi. Let's see if that will work. If we save this and go back to the browser, we do not get hi, and I think I know why. It's because we are not resolving our promise yet, so we won't be able to test this out. So maybe let's just resolve this and say hi here too, just to test it out. And there we go, it's resolved, so the promise gets back to us, but yet it's still not popping up Ethereum, which to me is very, very strange. Now let's go have a look at why that is. I'm going to go back and maybe let's move this code more down to the bottom, get rid of the hi console statement, close the port, and then maybe relaunch it again. I'm then going to close the browser, try and reset MetaMask and see what happens. So apparently what was happening is that I have other wallets that was connected to my dev server already. So what I can do now is I made sure I disconnected from them, and there we go. We can now connect to MetaMask. And there we have it. We are now connected. We can go back and now we can continue our journey. So the next step that we will need to do is actually go in here and create a Web3 instance. So let's create a variable and we're going to call it Web3. We're going to create a new Web3 instance. And this we get from the library that we imported. The Web3 takes in a provider and we're going to give it the MetaMask provider. Next, we need to create a new variable, and this one is going to be our contract. This time we're going to use the Web3 instance that we just created over there. We're going to say .eth and contract. The contract will take in our ABI, which we have imported, the JSON, as well as the contract address. So we're going to go to the contract and copy it over there. We will go back and paste it so that we can instantiate our contract. If we console.log this out now, we will be able to see our contract, and I can show you that on the browser. If we go back to our app, refresh, we can see that please use new. We will need to use new there. Go back and there's our fully laid out contract as well as our contract address. And now we're ready to interact and pull some data of it. As we know, a contract has a read argument, and the two functions that we will be using is the total supply, which is all the way down here, as well as our custom function which we made called getBuildings, this one over here. So now what we can do is go back to our program, go back to the code, and simply use it. So we're going to call web3, then .eth, and then we're going to say get accounts. So what get accounts will do, it's a promise as well, so we have to wait for it to resolve. But these will have all the accounts that's associated to the MetaMask account. And just to show you, if I console.log this out now, and I console.log the accounts like it is, and I go back to the app, and I refresh, I will see that we have a promise, and this is, don't use a comma, use a full stop. And we get back, we can see there's our list of addresses. The one that you are connected to will most probably be the very first one in this list. So we will refer to it as the accounts, but then append a 0 because we want to query the 0 index 1, meaning the first one in this array. While inside this promise statement, we can now go ahead and use the contract that we created. We're going to say contract.methods, and then we're going to call the method that we want. So we want the total supply, and we query it like this. We append the call method, and then we specify where is this from. Now we know that this is coming from the accounts 0 index. This is a promise too. So that's why we need to say then and wait for it to resolve. We're going to do this. And if I want to console.log this out too, we will simply get the data. So I'm going to call this as the supply. And let's log out the supply. If I go back, we will see that this is 0 indeed, because there's no NFTs that's been minted yet. But why would we need the supply? Well, we only want to show the NFTs to the supply that's been minted. So that's why we're going to do the exact same thing this time from a contract point of view. But this time, instead of calling total supply, we're going to call get buildings, like so. We still query it from our contract. But then instead of supply, we're going to refer to this as the data. And we're going to respond because we now need to return our initial promise. But the response is going to carry two things. The supply, which will be the supply. And in JavaScript, if you have two of the same variable key names, you can just use one, but I'm going to use both. Then we have the buildings, which will be the data that we get back. And that is it. Now we can go back to our index.js and complete our metaverse. Remember, we created this box geometry over here. For now, I'm going to take this out, but I'm going to actually cut this out, as well as get rid of this scene.add box. If we save our program now and we go back to it, there's nothing displayed. This is where we will now read all the data and actually do some cool magic. I hope you guys are ready for this because now everything comes together. In the connects promise coming back, remember we will have a result. So I'm going to refer to this as the result up here. For now, I'm going to console.log the result so we can see what we have to work with. If we go to the browser, we can see that now we've got a supply, which is 0, and a list of all our buildings coming directly from the smart contract. We can now use these individual links to kind of display what we need to see. So going back here, leaving the console.log in there, I will now loop over the buildings. So I'm going to use a for each. A for each looks like this, where it takes in an array. And the array that we're going to be working with comes from the result.buildings. Because if you can remember, we have the buildings as an array. So we can say result.buildings and then for each element, but this time I'm going to make this maybe just B. And we're also going to need the index. So add the index in there like so. Because in here, I want to actually check if the index of whatever we're looping over is less or equal to the result dot supply. Because we don't want to show buildings that really haven't been minted yet. Now we can paste back our geometry pieces in here. Instead of giving it static values, we're actually going to refer to B, which is our building over there. And we're going to say b.w, b.height, and b.d, so for depth. Then we have our material being created, which is fine for now. We also have our mesh, which is being created through the box geometry. And this we're also going to change. We're going to say this is the bx, this is the b.y, and lastly, this is the b.z. We still have to add it to our scene. So there we go, scene.add, and then after that, we add our box. And ladies and gentlemen, if I'm not mistaken, why is this not working? Oh, ladies and gentlemen, this is it. I hope you guys are ready for an awesome experience right now. Before I show you the magic, please just go to the Connect and just call this buildings instead of only building. So it should be buildings. I'm going to save that and now show you the magic. So we're going to go back to our app, refresh the page, and we can see that we connected and we can actually see the buildings and supply coming through. Yet, we can see no buildings. But let's go to Polygon scan. Let's go ahead and write to our contract. Make sure that you connect to MetaMask and that you are connected to the correct account. I am now connected, and now I can actually mint an NFT. How exciting! In the mint function, function number 2, I can enter the amount 0 because I don't need to pay anything. And I'm going to mint 2 NFTs, meaning that I am hopefully going to see 2 buildings pop up very soon. I'm going to confirm the transaction and then actually on another tab, view the transaction taking place. And there we have it. The 2 NFTs was minted successfully. We can also see this on the contract over here. And ladies and gentlemen, if I now refresh, fingers crossed that this will work and we should see 2 buildings appear. I'm refreshing, it's loading the data, and there we have it. Our 2 buildings, each one an NFT in its own right. We can do this process again by simply minting, let's say, another 3 NFTs. I'm going to confirm the transaction, and this time make it way faster so we don't have to wait. Confirm it, and let's simply view the contract. As soon as these go through successfully, we should be seeing another 3 NFTs popping up. So just verifying and waiting for the contract, loading it, and anticipation is kicking in. So let me load this. It was successful. So let's refresh our dApp. Refreshing it, and there we go. These 3 are 3 new NFTs that just popped up. Thank you so much for looking at my video and actually following my tutorial guide. I highly appreciate it, and if you guys could give this video a like, a comment, and subscribe, I would highly appreciate it. Also remember, I started a new YouTube channel, which is called HashLips 9 to 5. So if you go and type in HashLips 9 to 5, you should find my brand new channel where there's only one video on. There's already 400 subscribers, which is super exciting, but go and join that channel too. I'll be doing a lot of cool things there as well. Apart from that, I hope you guys are having an amazing day. Cheers for now, and I'll see you